Alright guys, welcome to shell permissions. So in this lesson we'll be covering the ch mode, the su, the sudo, the ch own, the ch group. Okay, so each of them has their own uses. Okay, they're like commands actually, so we're going to focus on those commands. So firstly, we are going to look at how to modify file and directory access rights. So there are actually two methods of doing that. We have the absolute method, or which we can call the octal notation method, and we also have the symbolic method. So in this video we are going to focus on the first method, the octal notation method, which is also known as the absolute method. Alright, so let's start with file permissions, then we'll move to directories permissions. So for the file permissions, on a Linux system, each file and directory is assigned access rights for the owner of the file, the members of a group of related users, and everyone else. So rights can be assigned to read a file, write a file, and to execute a file. All what this is just trying to say is that we are giving any file we choose to create, okay, we are giving it some access rights of our own choice, okay, whereby we can specify maybe public users can get to access it or not, or their limitation on what they can use that file for and what they cannot use that file for. You get, so you are setting boundaries to whatever files you are creating. Okay, so the rights of someone that can easily choose to want to delete the file or not delete the file, it's your choice to select who you want to access that features of deleting feature or adding feature or modifying the content of the file. So that's just what this whole permission stuff is all about. So we want to look at the octal notation method first. So it is easy to think of the permission settings as a series of bits. So using the octal notation method, actually this method is more like, I feel is the generally best method. Okay, it has no limitations in a way at all. Okay, so it's actually one of the methods we really need to know. Okay, although the symbolic method is also good, but the symbolic method is more like a, how would I put it, a single focus access rights. Like it's directly to a, it's kind of like limited in a way, and it's kind of like too straightforward in terms of what you want to do something quick, or want to set a unique quick access right in a specific user or something like that. But this octal notation will make you do everything well arranged, as if you are doing it from scratch in a way. Okay, and this time around I'm going to explain this. I'll break it down using binary and then converting it to base 10. So for example, now you've seen this kind of stuff before in your files. So let me just show you an example of what all this stuff looks like. So I think these are my files. So if I do ls-l to list it in a long list, so all this stuff we are seeing is what we are talking about today. So all these r, w, r, dash, all those stuff is what we are going to talk about today. Now if you notice, it starts with dash. So anyone that starts with dash means they are files, and anyone that starts with letter d, it means they are directories. Okay, as you can see, obviously. Okay, so that's, just keep that at the back of your mind. So after that dash or after that d is the whole file permission stuff which we are looking at today. Okay, so for example, now if we have a permission like this, mind you, all these spaces I'm putting in the real sense, there are actually no spaces. Okay, I just need to put those spaces just so you can differentiate between them, because if you even really look at it well here, you can see all of them are joined together, jam-packed together. Okay, so just for explanatory purpose, I chose to split it because of the usually group in three sections. So the first section here is the owner, that's like the admin. Okay, while this next three section is a group, so it can be like a group of admins, depends if you are doing some kind of remote projects or group projects. While this other one is like other user, that is like just any user, anybody can just access it, be it owner, be it group, or be it just a normal user. Okay, so that's the third and last access rights aspect. So now if for example we enabled, like obviously all these places, all of them are enabled here, because of me putting r means I've allowed it to be writable by the owner, me putting w means I've allowed it to, readable, the r means read, w means write, x means execute. So me enabling this feature for the three groups means they have all the rights for everything. Okay, so now we're going to represent each of those rights as bits. Okay, so if we put R, we're going to put represent as 1. We put W, represent as 1. Put X, represent as 1. That's what we'll do for the remaining two groups. Okay, so looking at this other example, you see the same pattern. So since we enabled read, we enabled write, so I'm going to put 1 1 and 0 means like off. So just as if it's like on and off. So we are owning the read feature and the write feature, but you can see we have dash after it, which means we off the execute feature. So that's why it is 0 here. It is binary. Same goes for the group, same goes for other users. Okay, so that's just what is here. Lastly, the same format here, we own the whole first three for the owner, the admin itself. So that's why everything is on, which is 1 1 1. But the rest are off for the group and the other users, so they are off. So that's why it is 0 0 0. So I believe you understand this very well now. Now moving forward, now after you've like outlined it in this format, then it's for you to convert each of them to base 10. So I believe we already know how to convert binary number from base 2 to base 10. Let me see if I can get a picture. So just a quick recap. Like let's say for example, this is a binary. Obviously, this is a binary number. When we say binary, we're talking about base 2 numbers. Okay, so anything that is 1 and 0, these are binary numbers, and you want to convert it to base 10, which means you'll start counting from the right. So this will be 0 1 2 3 4. Okay, so that's the counting we're going to give it at the top. So since we're in base 2, so this is automatic base 2. So it's going to be 1 times 2 raised to power 0, 0 times 2 raised to power 1. So just like that, just the way it is outlined like this for each of them. So put in their values and we're going to add everything together. So adding all of them together, which is the addition that was done here, gives us 25. Okay, so this 25 just for the whole of this binary at once. So in base 10 gives us 25. So that's just a quick recap. Alright. So that's what we're going to be doing here. So for example, now this place, so we have read, write, execute, all of them are on, which is 1 1 1. So I have to convert this 1 1 1 base 2 to base 10. So if you do the mathematical stuff, just do it, solve it with your jotter, convert base 2 to base 10, convert 1 1 1 base 2 to base 10, it should give you 7. Okay, the same thing goes to this place. We have RW dash, so 2 are on there, the last one is off, so 1 1 0. So 1 1 0 base 2 convert to base 10 to give you 6. So that's how we're going to do the rest also. R dash W, which means on off on, which is 1 0 1. So convert 1 0 1 base 2 to base 10, it should give you 5. Same with this last one, same with this last one. Okay, so that is it about that. So let's see example of how all this stuff can really be applied or given the final answer to. So let's say, for example, if I want to create a file and the name of my file, I want to name the name of the file as file name. Okay, so that's the name of the file. Now in that file, I want to give it some permission. So the permission I want to give it is that I want only the owner to be able to read and write that files. Okay, so I want only the owner to be able to read. When I say owner being able to read, when it comes to a file, when I talk about reading a file, it's for you to like see what is inside the file. So that's what that read means. Okay, so just like when we'll be doing cat, remember that cat command. So it's another way of reading the file to see what is inside that file. So I'm only giving the access of the owner to be able to see what is in the file. That means group can see it and other users can see it. It's only the owner or the admin, okay, of that file that can have access to seeing what is inside the file content itself. So that's what really means. And the aspect of writing is just like the way it writes, just like you using your Emacs or using your VI or using your Echo to put in some content inside. So which means it's only the owner that can write content inside that file. That means other people, other users and group can't write it. So that's what this condition is saying, that we should set a permission that will follow this rule. So the rule is that it's only the owner that can read and write, which means since we said only read and write, that means the owner self cannot execute. So that means X can see the owner will have only read and write, and the execute part will load dash because we chose not to give that permission to ourselves as the owner. Okay, now for the group, but okay, the questions there continue that but wants to keep the file private from others. So when you say private for others, that means the group and other users have no access to it. So I'm just going to give them dash dash off everything, off all the features for them, so they don't have any access to it. Only I, the owner, have access to the file in terms of reading the file and writing content to the file, though I don't have access to execute unless I set it up for myself. Okay, so from this output here now, since you know the read write the rw dash, that is 110, then this rest are 00000. They convert each of them to base 10. So we have the first one as 6, we have the other one as 0, we have the other one as 0. So therefore our final result will be chmod 600. That's what we're going to put in. We're going to put in those base 10 value. So 600, then the file name. So that's how to set all these kind of commands for each of those files. So let me just go to my Ubuntu and let's just see a quick example of it. Okay, so I've already do ls-l to see those permissions for each file. So let's take, for example, we want to change this first file. So this first file here, which is one file, that's the name of the file. So let's look at the permission. The permission is that the owner, me, I can read and write, but I can't execute. But the group can just read only, and the other users can also just read only. Now let's set it to this particular way. We want the group and the user not to be able to read at all. They shouldn't be able to do anything, which means all their own region should be in dashes only. Okay, so I want to be the only one that can read and write. So that means I'm going to write chmod 600, then the name of the file. Okay, so that will be chmod 600, then the name of the file is one-file. Enter. So let's check. I'll do ls-l to see the permissions. You can see the permission has changed. Let me just scroll back up so you can see the previous one and the new one. So this was the previous one up here. This is the new one. You can see the new one. We have dash 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 for the owner and the users. So they don't have any permission. Everything is private to them. Like they can't access the file for anything. I'm the only one that can read and write the file. But previously, the owner could read and the user could read. But now I've set it that even them too, they should not be able to read what is inside it, which means whenever they want to use cat command won't work for them. That's what it means. And if they want to Emacs or VI to view what's inside the content, it won't open for them. It's only open for only me because I'm not set it that way. So that's just what the whole feature stuff we're saying is all about. Alright. So we can just choose to modify or play around this. So if I say I want to on the read write for group also, and maybe should I on this one too, or let me just leave it. So I want to on the access right I have for myself. I want to run it for group also. So that means since I on this two, the read and write, so this will be 110. Then the last one is off. So I'm going to convert 110 base 2 to base 10. So I think we've already done that here. So it gave us 6. So that means this place also will still be the same 6. So we have, that means this file, this part will change to 660. Okay. So let's see it again. So we want to update this same file 1. Okay. So instead of it having this access, we want to change the access again to something else. So once both the owner, which is myself, and the group to have the same access rights, but other users should still be logged, so they shouldn't be able to do anything in that particular file. Okay, so for me to do that, I'll just need to chmod again. So I chmod 660, then the name of the file. Enter. So let me check it. So you can see now it has changed to rw-rw-. So both the group and the owners can read and write, but the users can still not do anything. Alright, you can see the previous one, group and users couldn't do anything. It is private to them, but now I've enabled the group only. Alright, so that's just how to play around this. Okay, so that's just how to just understand that represents each of them in binary. Anyone that is off, put it as 0. Anyone that is on, put it as 1. Then convert each of them to base 10. So once you convert each of them to base 10, so now give you the total value of everything. Like for example, now this one now, the total value of this one is 666. because the binary of 111 base 2 is 6, and the same thing as 111 base 2, 111 base 2, so that's 666. That means here will be 666. That if you want to update it in this format, so it will look like this format, so everything has all the old features, so it will give you, you have to use the 666 and the name of the file. So that's just how to play around everything. All right, so that's it about files. So now let's quickly move to directory permissions. Now the directory permission is actually still similar to the file permission, just that it has a different meaning. Like the R, the W, the X has a different meaning, but the way we got all these values are still the same format of way. Nothing changed. Okay, when I'm talking about the binary aspects now. Alright, so nothing really changed at all in this place. Wait, I think I made a mistake in that R. This is 111, so this should be 7, not 6. 777. Okay, because 111 base 2, you can see 111 base 2 to base 10 is 7, so this should be 777. So if we are following this particular, I want to make this all access rights to be enabled for all of them, so we're going to use that. We're going to use 777 here. So yeah, that was a mistake. Glad I saw it early too. Okay, so now we're in the directory permissions again, so just the same format in terms of doing the binary stuff. The only thing you just need to notice is the difference in the meaning. So when it comes to directory, the meanings are different in terms of the read, write, and execute. So when in terms of the reading, what the reading means in directory aspect, remember the other one we were doing was file aspects. So when it comes to directory aspect, this R means listing. That means this ls command. So that's what it just means. Okay, so R allows the contents of the directory to be listed. What that statement means is that, wait, let me clear this screen. Now I'm already in a directory here. You can see I'm in this directory named dev.plus. So, and if I do ls, it lists everything, which means I have a permission to list. That's why it worked for me. So I can set it that way that I want to have permission to list something inside the directory. So that this listing stuff is the read aspect. So now let's see for us. Let me go up. And let me check the permissions for this dev.plus. So the dev.plus, you can see D means it's a directory, then the first thing is RW write, which means I can read the directory, which means I can list the directory. That's why this ls command worked for me. If this read wasn't enabled, if it is dash, that means this ls won't work for me at all. So that's what it means. I don't know if you've noticed, if you go to your Ubuntu, you go to the root directory itself. If you do cd root, yeah, you can see permission denied. So the people that created this Ubuntu software, they have already blocked me in a way that I can't list, or I can't enter rather. So I can't enter inside this cd root at all. So they didn't give me permission for that. So this kind of notation, this kind of warning sign of telling me that I don't have permission, that's what it will show when it, but if it's another user that opens it, or that we are restricting certain things to them. Alright, so just keep that at the back of mind. So that's what we've just been saying here. Okay, so for me to do cd dev.plus save and enter, there's a permission for that also, which we are still going to see here. So the aspect of the R means making the ls command enabled. Okay, so which means I'm setting a feature that some access feature, probably for the owner of order or group, to be able to have that access of doing certain things. Okay, so this R, me setting this R means I can do ls command. Okay, so something like that. So next one is the W. So the W means create, like we know it is write in terms of file, it means like write, right? But yeah, in directories it means I can create, I can delete, and I can rename anything that is inside a directory. So I can create, I can delete, and I can remove and rename anything that is inside that directory, which means it can be a file, it can be another directory, and that directory itself. Okay, so that's just what it means there. So let me show you an example of what I'm trying to say here. Still looking at the dev.plus, I think we've done that. So looking at the dev.plus, you can see I have the permission to write That's the W is there, which means anything that is inside that dev.plus, I can choose to create a file inside it, which are all these files I created here. And I can choose to delete it because I'm giving the permission to delete. So I can choose to delete any file that is inside here. So I'm just deleting some file now. Because the reason this deleting is okay because of I have the enablement to do that. Okay, so it cannot remove no such file that. Okay, yeah, I made mistake. CKL, not CK1. I think the rest deleted too. So CKL, good. So that's just all what we are just trying to say here. Okay, so it's usually advisable though that when it comes to directory, make sure the first three is on for yourself. At least in short, the first two especially in terms of the directory. Okay, so because you really need those first two, you need to see what is inside it, which is the aspect of the read part. You need to be able to do ls here. I need to be able to delete and remove files that are inside your directory. So if you go and lock yourself, you can go and mistakenly lock yourself in a directory. So don't go and make that mistake to lock yourself in a directory. In terms of if you want to create a directory, then you won't be able to delete that directory for life if you make that mistake. What I'm trying to say is that, for example, now I think I have this directory called dir1 here. So let me do ls-l. So I have dir1 here. If you look at the permissions there, I can read, I can write, I can execute the dir1. Okay, so imagine if I remove this right there. So if I remove this right there, it will mean that I can't create anything I can't create a file inside this dir1. That's what it means. I can't create anything, I can't delete the file that are there itself. So I'll just be like stuck there in that way. So it doesn't really make any sense at all. So the same thing happens to if I want to create a directory now. Like this permission here, this dir1, I can choose to, if I want to change the permission in terms of the owner here, that means I have to put in the parent directory, which is this dev.plus. Okay, so that's just what it means for me to be able to set what will happen inside this directory itself. So this thing may look kind of like tricky in a way. So the last one, the X allows a directory to be entered in terms of cd command. All right, so you need to understand that when it comes to directories, or when it comes to creating a permission for directory, always X must be there. Like cd command must be there for the owner in particularly. Okay, so you can choose to set whatever set you want to set for group or an other user. I can see this space we made it private for group and other users. Here we made it private for on only writing. So that means they can't create a file inside, they can't delete it, they can't rename it, or they can read it, as in they can see what is inside the file. They can do ls to see what is inside the directory rather. Okay, so that's what it means for both the group and the owner. So, but if you notice something here is common. RWX is always on all of them. So don't make that mistake of offering this RWX for your directories. Okay, very, very important. Unless you go and lock yourself, you won't be able to delete that directory again for life. You go and mistakenly lock yourself out by trying to maybe play around or test certain things. So if you want to test anything, you can test anything using all these other aspects here. Okay, that's the R-X and the other when it comes to group and when it comes to users. So just get that at the back of your mind. Okay, and moreover, the R and the W cannot work without X being involved. So you have to make sure X is enabled for R and W, which means I can choose to do like this, something like this, R-X, or I can choose to do R-WX, but I can't do RW dash. Like it can't work, it won't even work for me, the permission won't work. So we always need X to be present, but the first two can be removed if you want it to be removed. Okay, so that's just it about that anyways. But I would just advise you to always leave everything on when it comes to the owner aspect, but the rest one, the group and the users, then those ones can now put the limitations for them. Or the admin is supposed to have access to all the rights. Okay, so the admin is supposed to have access to them, only the groups and then the other users that are just using the application, you can choose to then limit their own rights so that they won't spoil the file for you, or they won't spoil the directory for you. You understand? So that's just the purpose of this whole permission concept, so I explain it here. Okay. So I'm trying to see if I'm missing anything. Okay, I think we are good to go. So that's just it about this whole aspect. So this first condition here is we are giving no restriction at all. So no restrictions on permission. So everybody have the same rights. That's what this first place means. Okay, so everybody here has the same rights. So for example, now since we're dealing with directories this time around, so if I want to create a directory, or in short, just like this dir1, let's use the same dir1. If you notice this dir1, the admin has the RWX, all the permissions is set for the admin, but the group, not all are set. Also the user, not all. The middle part, the right aspect is not set for them, which means they can't create anything there, they can't delete anything there, they can't rename anything that is inside that directory. Okay, but now I can choose to set it for them so that they will be able to do it. So for us to do that, I'm just going to do chmod, and I'm going to do the binary stuff since I'm owning them. So this will be 111111111. So converting each of them to base 10 will give me 777. So that means chmod 777. That's what it means. So chmod 777, then the name of the directory. Enter. So if I do ls-l now, we'll see the difference. Let me scroll up so we can see. I believe we're already seeing the difference itself. I see the first one here, the dir1 up here. So this is the new one which I updated. And see it, I gave it all these permissions like this. In short, that is why it made this place colored itself too, and it made it different from looking at this dir1 here. So this colored aspect, this green color has shown that this feature has been given to everybody to have some rights permissions, because everything is on here. RWX is on for both the group, both the owner, the admin, and both the end users. Okay, so that's just how to play around this. So similarly with this one, I think this one was exactly what we had before we created this last one in terms of our dir1. So this permission here, the owner or the admin has all the rights, but the group and the end users, those ones have limited rights. They can only read, which means they can only do ls to that directory, and they can execute the directory, but they can't create anything inside the directory. Even if they only see the things I've created there by doing ls, but they can't touch it, they can't delete it, they can't change anything there. It is as I've put it that they will always see it there. They can't add their own to it or delete it or delete anything from it. So that's just what it means in all this permission stuff. So the center of this last one, this one I gave all the permission to myself, and I made everything private to the rest, so they can't do anything at all. Compared to this one, this one, the group and users can still do something. They can read and they can execute. But this time around, this one, they can't even do anything at all. So that's just the difference here. So I believe that is all about that for this first aspect of absolute method. So this absolute method is very, very flexible, honestly. Like, you can really use it. It's very flexible. You can specifically do those features. So let's say, for example, if you want to start afresh, like if you want to think of permissions to do, so the first thing to do is just to write it down. Write write for the admin, write for the group, write for the user. Like write the permission down with your Bible first. If you want to write, you want to read, you want to execute. So after writing it down, or you want to off certain one, put a dash, then do the binary stuff and convert it to base 10. Then you can also set it directly. So you can see it's actually very easy to use. So next we'll be looking at the symbolic method in the next class. All right, so hope you understand the previous method very well. So take care, bye.